Tonight, we're going to drift into something absolutely extraordinary. Something you see every single day but probably never really think about. We're talking about Earth, our planet. This spinning blue marble floating through the void of space that somehow, against all odds, became the perfect home for life. For us, for everything we've ever known. And the story of how that happened, how this planet became what it is today, is honestly one of the most incredible tales you could ever hear. Before we begin, feel free to comment your time and location below. It's always amazing to see when and where we're all watching from, or gently drifting off. The visuals are here for you, but there's absolutely no problem if you doze off midway through. Actually, that's kind of the point. Let your mind wander across continents and oceans, through time and space. I would encourage you to watch till the end, to learn many new things. But if sleep finds you first, that's perfectly fine. And if you find comfort in these gentle explorations of our world, I'd be grateful if you'd consider subscribing and liking this video. Let's begin. So, here's the thing about Earth. We think of it as permanent, right? Solid, unchanging. The ground beneath your feet feels stable. The mountains have been there forever. The oceans have always been where they are. But that's not really true. Not even close. Earth is actually this constantly shifting, churning, evolving system that's been transforming itself for about 4.5 billion years. And I mean constantly. Right now, as you're listening to this, the ground is moving. Continents are drifting. Mountains are growing. Others are eroding away. The ocean floor is spreading. Volcanoes are building new land. Earthquakes are reshaping coastlines. It's all happening. Just too slowly for us to notice in our brief human lifetimes. But it's happening. The Earth you're standing on today is not the same Earth that existed 1 million years ago. Not even the same Earth from 1,000 years ago, really. It's always changing, always moving, always becoming something new. And that's what makes it so fascinating. Because to understand Earth, you have to understand that it's not a thing, it's a process, a 4.5 billion year process that's still ongoing. Let me put this in perspective for you. 4.5 billion years, that's how old our planet is. But what does that even mean? How do you wrap your head around that kind of time? You can't, really, not fully, but let's try. If you compressed Earth's entire history into a single 24-hour day, humans would show up at about 11:58 p.m. We've been here for 2 minutes. 2 minutes out of an entire day. All of recorded human history, everything from the pyramids to the internet, would happen in the last few seconds before midnight. That's how young we are. How recent. The Earth has been doing its thing for billions of years without us. It'll probably keep doing its thing for billions more after we're gone. And during all that time before we showed up, Earth was busy. Incredibly busy. It was forming continents, creating oceans, building mountain ranges, generating an atmosphere, figuring out how to support life. And the life that emerged changed the planet right back. It's this incredible feedback loop. The planet shapes life. Life shapes the planet. Back and forth. For billions of years. Here's something that might blow your mind. Earth wasn't always blue. When it first formed, it probably looked more like a ball of molten rock. No oceans, no atmosphere, at least not one we'd recognize. Just this hellish sphere of liquid stone spinning through space. The early solar system was chaotic, right? Debris everywhere. Rocks smashing into each other. And Earth was just one of those rocks, gradually accumulating more material through countless collisions. Each impact added mass, added heat. The whole planet was molten, a magma ocean covering the entire surface. No solid ground anywhere, just liquid rock as far as you could see, if there was anyone to see it, which there wasn't. And it stayed that way for millions of years, maybe tens of millions. We're not entirely sure. But gradually, very gradually, things started to cool down. The surface began to solidify. The first solid crust formed. And this is where things get interesting, because once you have a solid surface, you can start to have geology. You can have processes. You can have change that's more complex than just a ball of liquid rock cooling down. The formation of Earth's crust is still something scientists argue about, actually. We think, and this is our best guess based on the evidence we have, that the crust formed in stages. The very first crust was probably pretty thin, unstable. It would form and then get remelted by volcanic activity or broken apart by impacts. The solar system was still pretty violent back then. Lots of stuff still flying around. Earth was getting hit regularly by asteroids and comets. Some of these impacts were absolutely massive. There's this theory called the giant impact hypothesis, and it suggests that early in Earth's history, maybe 4.5 billion years ago or so, a Mars-sized object crashed into Earth, just completely smashed into it. And the debris from that collision, along with material effluent on Earth itself, got thrown into orbit and eventually coalesced into the Moon. The Moon, our Moon, formed from the remnants of a catastrophic collision. How wild is that? And this impact, if it happened the way we think it did, would have completely remelted Earth's surface, back to square one. Magma ocean all over again. But it also gave us the Moon, which turned out to be pretty important for Earth's development. The Moon stabilizes Earth's rotation. Without it, our axis would wobble chaotically, which would make climate completely unpredictable. So that giant devastating impact might have actually been necessary for Earth to become habitable later on. After things settled down from the Moon-forming impact, Earth started cooling again, and this time, the crust that formed was more stable. It stuck around, and gradually, very gradually, water started to appear. Now, where did Earth's water come from? That's another thing we're not completely sure about. There are a few theories. One idea is that water was delivered by comets. Comets are basically dirty snowballs, right? Ice and rock mixed together. And if enough comets hit Earth during the late heavy bombardment, which was this period about 4 billion years ago, when the inner solar system got pelted with debris, they could have brought water with them. Another theory is that water was already present in the materials that formed Earth, locked up in minerals, and it got released through volcanic activity as the planet heated up and cooled down. Or maybe it was a combination of both. Probably was, honestly. But however it got here, water accumulated. At first it was all steam because the surface was too hot for liquid water to exist. But as things cooled, that steam condensed. It rained, and it rained, and it rained for thousands of years, maybe longer, until the oceans formed. The early oceans were probably pretty different from what we have now. They were hot, acidic, full of dissolved minerals from the rocks. Not exactly a pleasant place for a swim, but they were oceans, liquid water covering much of the planet's surface. And this changed everything, because water is this incredible substance. It's a solvent, which means it can dissolve lots of different materials. It can transport things. It can store heat. It can erode rock. It can shape landscapes. And most importantly, at least from our perspective, it can support life. But we're getting ahead of ourselves. Before life could emerge, Earth needed to stabilize a bit more. It needed an atmosphere, something to protect the surface from radiation, something to regulate temperature. And early Earth's atmosphere was nothing like what we breathe now. There was no oxygen, or very little. It was mostly carbon dioxide, nitrogen, water vapor, maybe some methane and ammonia. Toxic to us, but that was the atmosphere. And it was probably created through volcanic outgassing, volcanoes spewing gases from Earth's interior into the air. Over millions of years, this built up an atmosphere. Not a pleasant one, but an atmosphere nonetheless. Now, the thing about early Earth is that everything was happening at once, kind of. The crust was still forming and reforming. Volcanoes were everywhere, constantly erupting. The atmosphere was developing. The oceans were filling up. And beneath it all, the interior of the planet was organizing itself into layers. See, when Earth was molten, the heavier elements sank toward the center, and the lighter ones rose toward the surface. This created Earth's layered structure. At the very center, you have the inner core, which is solid iron and nickel. Surrounding that is the outer core, which is liquid iron and nickel. Then you have the mantle, which is solid rock, but it can flow very slowly over long time scales. And finally, the crust, which is the thin solid shell we live on. This structure is crucial because it drives plate tectonics, which we'll get to in a bit. But the point is, Earth was sorting itself out, organizing, becoming more complex. And all of this was setting the stage for something truly remarkable. Life. We're not sure exactly when life first appeared on Earth. The earliest evidence we have is from about 3.5 to 4 billion years ago. Fossils of simple microorganisms, or at least structures that we think were created by microorganisms. It's hard to be certain with rocks that old. But life probably started even earlier. Maybe as soon as the oceans formed and the surface cooled enough. And we don't know how it started. That's one of the biggest mysteries in science. How does non-living matter become living matter? How do you go from chemicals to cells? There are lots of theories. Maybe it happened near hydrothermal vents on the ocean floor, where hot mineral-rich water was spewing out. Maybe it happened in shallow pools on the surface where lightning and UV radiation could provide energy. Maybe the building blocks of life came from space, delivered by meteorites. We just don't know. But somehow, somewhere, chemistry became biology. And once it did, evolution took over. The first life was simple. Single-celled organisms, bacteria, archaea, living in the oceans. And for billions of years, that's all there was. Just microorganisms. But these tiny creatures were transforming the planet. Some of them, called cyanobacteria, figured out how to do photosynthesis. They could take sunlight, water, and carbon dioxide and turn it into energy, releasing oxygen as a waste product. And this oxygen started accumulating in the atmosphere. At first, it got absorbed by rocks and dissolved iron in the oceans. But eventually, maybe around 2.5 billion years ago, oxygen levels started to rise significantly. This is called the Great Oxidation Event, and it was catastrophic for most life at the time because oxygen was toxic to the organisms that had evolved in an oxygen-free world. But it also opened up new possibilities. Oxygen allowed for more efficient metabolism. It made complex life possible. Without the Great Oxidation Event, we wouldn't be here. So thank you, cyanobacteria, for poisoning the atmosphere with oxygen and making everything more complicated. After oxygen became abundant, life started to diversify. Over the next billion years or so, cells became more complex. Eukaryotic cells evolved, cells with nuclei and organelles. These could do more things, be more specialized. And eventually, maybe around 600 million years ago, multicellular organisms appeared. Life that was made of many cells working together. This was the Cambrian explosion, this period where life suddenly, relatively speaking, became incredibly diverse. All sorts of weird body plans appeared. Trilobites, Anomalocaris, things that look completely alien to us now. And from this burst of diversity, all the major groups of animals we see today trace their origins. Fish, amphibians, reptiles, mammals, birds. All came from this period of incredible experimentation. And as life diversified, it continued to change the planet. Plants moved onto land, which changed the soil, changed the atmosphere even more, changed the climate. Animals followed, ecosystems developed, and the Earth kept spinning, kept changing, kept evolving. This feedback between life and planet has been going on ever since. It's still going on. Right now, as you listen to this, we're living in that feedback loop. Every breath you take, you process that cyanobacteria figured out billions of years ago and are part of it. The oxygen you're breathing, it came from plants, from photosynthesis. From that same when you exhale, you're releasing carbon dioxide back into the atmosphere, which plants then use. It's a cycle, a system, and we're embedded in it. We are always here. But let's talk about extinction for have been. We always will be, as long as we emit it, because it's not like all this evolution and diversification just happens smoothly. There have been interruptions, big ones, mass extinctions, events where a huge percentage of life on Earth just died, gone, wiped out. There have been 5 major mass extinctions in Earth's history, maybe more depending on how you count them, but 5 really big ones. The most famous is probably the one that killed the dinosaurs, the Cretaceous-Paleogene extinction, about 66 million years ago. An asteroid, maybe 6 miles across, slammed into what's now the Yucatan Peninsula in Mexico. The impact was unimaginable. The energy released was equivalent to billions of nuclear bombs. The heat from the impact ignited wildfires across the planet. Dust and debris were thrown into the atmosphere, blocking out the sun for months, maybe years. Photosynthesis stopped. Temperatures plummeted. Flew all the non-avian dinosaurs. But that wasn't even the worst. Extinction chains collapsed. And about 75% of all species went extinct, including event. The worst one happened much earlier. The Permian-Triassic extinction, about 252 million years ago. This one is called the Great Dying, and it's an appropriate name. Somewhere around 90 to 95% of all marine species went extinct, and about 70% of terrestrial species. It was the closest life on Earth has ever come to complete annihilation. We're still not entirely sure what caused it. Maybe massive million years. They would have released enormous amounts of carbon dioxide and other volcanic eruptions in Siberia. These eruptions lasted for maybe gases into the atmosphere. This would have caused global warming, ocean acidification, oxygen depletion in the oceans. Everything that could go wrong, basically, went wrong. Life barely survived, but it did survive. And after each of these mass extinctions, life bounced back. It took time, millions of years sometimes, but new species evolved. New ecosystems developed. The niches left empty by the extinct species were filled by survivors who adapted and diversified. Evolution doesn't stop. It can't stop, really. As long as there's life, there's evolution. So mass extinctions are terrible, catastrophic. But they also create opportunities. They reshape life on Earth. They're part of the story. A violent part, sure, but part of it nonetheless. And we're living in the aftermath of the most recent one. We're beneficiaries of that extinction event that killed the dinosaurs. If it hadn't happened, mammals might never have become dominant. Humans might never have evolved. We owe our existence in a way to that asteroid, to that catastrophe. It's a strange thing to think about, But now let's jump forward. Let's talk about humans, because we're the ones telling this story after all. And we're also the ones changing the planet now. Humans evolved in Africa. Homo sapiens, our species. Maybe 300,000 years ago, give or take. We're not entirely sure, but somewhere around that time. And for most of our history, we were just another species, hunter-gatherers, living in small groups, using tools, using fire, but not fundamentally different from other animals in terms of our impact on the planet. We were part of ecosystems. We hunted, we gathered, we moved around, but we weren't changing things on a global scale. Not yet. That changed maybe 10 to 12,000 years ago with the development of agriculture. The Neolithic Revolution. Humans started domesticating plants and animals, started settling down, building permanent settlements, and this changed everything. Agriculture allowed for larger populations. It allowed for specialization. Not everyone had to spend all their time finding food. Some people could do other things, make tools, build structures, develop technologies, and human populations grew and grew and spread. We moved out of Africa into Europe, Asia, Australia, the Americas. We adapted to different climates, different environments, and everywhere we went, we changed things. We cleared forests for farmland. We diverted rivers for irrigation. We hunted large animals to extinction in many places. Aces, the megafauna that had survived for millions of years, gone within a few thousand years of humans arriving. Woolly mammoths, giant sloths, saber-toothed cats. Maybe climate change played a role, but humans definitely contributed. And then things really accelerated. The Industrial Revolution, maybe 250 years ago. Humans started using fossil fuels, coal, oil, gas, energy that had been stored in the earth for millions of years, from ancient plants and animals, compressed, transformed, and we started burning it, releasing that carbon back into the atmosphere. And this gave us incredible power. Machines, factories, transportation, communication, the modern world. But it also started changing the climate. Carbon dioxide levels in the atmosphere have been rising steadily since the Industrial Revolution, and they're higher now than they've been in millions of years. And this is causing global warming. The planet is heating up, ice is melting, sea levels are rising, weather patterns are changing, and this is happening fast, faster than most natural climate changes in the past. Ecosystems can't adapt quickly enough. Species are going extinct, and we're the cause, humans, US. So here's the thing. We've become a geological force. We're changing the planet on a scale that's comparable to some of the major events in Earth's history. Some scientists call this the Anthropocene, the age of humans, a new geological epoch defined by human impact. And whether or not that's officially recognized, the point stands. We're changing things. The climate, the oceans, the land, the atmosphere, the biosphere, everything. And we're doing it fast. Faster than the planet can adjust. Faster than evolution can keep up. And this is causing a biodiversity crisis. Species are going extinct at rates that might be comparable to some of those past mass extinction events. We might be causing the 6th mass extinction, right now, in real time. But here's the complicated part. Humans are also part of nature. We evolved here. We're made of the same stuff as everything else. Carbon, water, DNA. We're not separate from the planet. We're part of it. And everything we do, everything we've built, it all came from the earth. The metals in our buildings, the silicon in our computers, the energy we use, it's all from here. We didn't bring anything from outside. We can't. We're stuck here, on this planet, in this system, And whatever we do to the planet, we do to ourselves, because we depend on it, on the air, the water, the soil, the ecosystems. If we destroy them, we destroy ourselves, or at least we make life a lot harder for ourselves and for future generations. So what does this mean? I don't know. I'm not here to preach or tell you what to do, but it's worth thinking about. We're in a unique position. We're the first species, as far as we know, that's aware of our impact, that can study it, measure it, understand it, and potentially change it. We have technology, science, the ability to plan for the future. Maybe we can figure this out. Maybe we can find a way to live on this planet without destroying it. Or maybe we can't. Maybe we're just another species that will rise and fall, leave behind fossils for some future intelligence to discover and puzzle over. Who knows? But the Earth will keep spinning. It doesn't care. It's been through worse. 5 mass extinctions, asteroid impacts, volcanic eruptions, ice ages, hothouse periods, and life has survived. It's always survived. Maybe not the same species, maybe not the same ecosystems, but life finds a way. It adapts, it evolves, it fills the niches. Even if humans go extinct, life will continue. Something else will take our place. Maybe rats, maybe cockroaches, maybe something we can't even imagine. And the planet will keep changing, keep evolving, keep spinning through space. Because Earth is not a static thing. It never has been. It's a dynamic system, always in flux. The continents are still moving, the climate is still changing, volcanoes are still erupting, earthquakes are still happening, life is still evolving, and it will continue long after we're gone. The planet doesn't need us. We need it. And maybe, if we're smart, we'll figure out how to stick around for a while longer. How to be part of the system without breaking it. How to live on this planet in a way that's sustainable. But that's up to us. And we're running out of time to decide. So here's the thing about time. The planet operates on a time scale that's so different from ours that it's almost meaningless to us. We think in days, weeks, maybe years if we're planning something big. The planet thinks in millions of years, tens of millions, hundreds of millions. The processes that shape the Earth, they don't happen quickly, or at least most of them don't. Continental drift. That's happening right now. The continents are moving, slowly, a few centimeters per year, about the same rate your fingernails grow, which doesn't sound like much. And it isn't. Not on human timescales, but over millions of years, it adds up, a lot. The Atlantic Ocean is getting wider. Europe and North America are drifting apart, a tiny bit each year, but it's been doing this for about 200 million years. And in that time, the ocean has opened up, completely. Where there was once land, now there's thousands of kilometers of water, and it's still going, still spreading. The Pacific Ocean is shrinking, the plates are converging, subducting, one plate sliding under another, and eventually, maybe in another 200 million years or so, the Atlantic might start closing again. The continents might drift back together, form a new supercontinent. It's happened before. Pangaea was the most recent one, about 300 million years ago. Before that, there was Rodinia, and before that, others. The continents come together, break apart, come together again. It's a cycle, a slow grinding cycle that takes hundreds of millions of years to complete. And we're just living in one moment of that cycle, one snapshot. If you could speed up time, watch the Earth like a time-lapse video over billions of years, you'd see the continents sliding around the surface like puzzle pieces, colliding, splitting, rotating. It would look almost fluid, almost alive. But we can't see that. We're stuck in our tiny slice of time, where everything looks static, permanent, but it's not. Nothing on Earth is permanent. The mountains we think of as eternal, they're temporary. The Himalayas are still rising, being pushed up by the collision of the Indian plate with the Eurasian plate, a few centimeters per year. But they're also eroding. Rain, wind, ice, gravity, all wearing them down. Eventually the collision will stop, the plates will move in different directions, and the Himalayas will erode away, completely. Given enough time, and new mountains will form somewhere else. It's happened before. The Appalachian Mountains in North America, they used to be as tall as the Himalayas. Maybe taller, about 300 million years ago, when Pangaea was forming, but they've been eroding ever since. And now they're just worn down stumps, rounded hills, beautiful, sure, but nothing like what they used to be. And the same thing will happen to the Himalayas, and the Rockies, and the Andes, all of them, given enough time. Everything on Earth is temporary, even the rocks. The oldest rocks on Earth are about 4 billion years old, which is old, really old. But the Earth itself is 4.5 billion years old. So where are the rocks from that first 500 million years? They're gone, destroyed, recycled, melted back into the mantle, or eroded away, or metamorphosed so much that they're unrecognizable. The rock cycle is constantly destroying old rocks and creating new ones. Igneous rocks form from magma, cool down, get weathered into sediments. Those sediments get compressed into sedimentary rocks. Those rocks get buried, heated, compressed, turn into metamorphic rocks. And if they get buried deep enough, they melt, become magma again, and the cycle starts over. Nothing is permanent, and this is happening all over the planet, all the time. The seafloor is constantly being created at mid-ocean ridges, where magma rises up, cools, forms new crust. That crust spreads outward, gets older, colder, denser, and eventually it gets subducted, pulled back down into the mantle, melted, recycled. The oldest seafloor on Earth is only about 200 million years old, which sounds old, but it's nothing compared to the age of the planet. The seafloor is young because it's constantly being recycled, destroyed and recreated. And this process, this recycling, it's what keeps the planet active, what drives plate tectonics, what creates mountains, volcanoes, earthquakes. It's what keeps the Earth geologically alive. Some planets don't have this. Mars, for example, it's geologically dead, or mostly dead. There might be some residual activity, but nothing like Earth. Mars doesn't have plate tectonics. Its crust is one solid shell, and it's been that way for billions of years. The volcanoes on Mars, they're huge. Olympus Mons is the biggest volcano in the solar system, about 3 times the height of Mount Everest. But it's extinct. It hasn't erupted in millions of years, maybe hundreds of millions, and it probably never will again, because Mars is dead inside. Its core has cooled, solidified. There's no more heat driving volcanic activity, no more internal convection, no more magnetic field. Mars used to have a magnetic field billions of years ago. We can tell from the magnetic signatures in old rocks. But it's gone now, and without a magnetic field, the solar wind stripped away most of Mars's atmosphere, which is why Mars is a cold, dry, dead desert today. Earth could have ended up like that, but it didn't. Earth stayed geologically active. Its core is still hot, still liquid, still generating a magnetic field, and that magnetic field protects our atmosphere, deflects the solar wind, keeps our air from being stripped away. Without it, Earth might look like Mars. So we're lucky. Kind of. Or maybe it's not luck. Maybe it's just the size of the planet. Earth is bigger than Mars, more mass, more gravitational energy, more heat left over from its formation, and that heat is still driving everything. The convection in the mantle, the movement of the plates, the volcanic activity, the magnetic field, all of it. Heat. That's the engine, and it's been running for 4.5 billion years, and it will keep running for billions more, probably. Eventually, Earth will cool down, the core will solidify, the magnetic field will disappear, plate tectonics will stop, volcanic activity will cease, and Earth will become geologically dead, like Mars. But that's a long way off, billions of years. So for now, the planet is alive, active, constantly changing, and we're living on a planet that's in the middle of its life. Not too young, not too old, just right. Which is good for us, because if Earth were younger, it might be too volcanically active, too unstable, too hot. If it were older, it might be too cold, too dead, too boring. But right now, it's perfect. Or at least, it's perfect for life as we know it. And life, that's another thing that operates on these huge timescales. Evolution. It's slow, really slow. We can see evolution happening in real time with bacteria, viruses, things that reproduce quickly. But for complex organisms, for animals and plants, evolution takes a long time. Thousands of generations, millions of years. The species we see today, they're the result of billions of years of evolution. Tiny changes, mutations, natural selection, generation after generation. And the fossil record shows us how this has played out, how life has changed over time, how species have come and gone, how the dominant forms of life have shifted. There was a time when the Earth was dominated by single-celled organisms for billions of years. That's most of Earth's history, just bacteria, archaea, simple life. Then, about 600 million years ago, something changed. Complex life exploded. The Cambrian explosion. Suddenly, there were all these different kinds of animals, with hard shells, complex body plans, eyes, predators prey, ecosystems. It was a revolution, and we don't fully understand why it happened. Maybe oxygen levels increased, maybe some genetic innovation occurred, maybe it was just a threshold that life crossed. But once it started, there was no going back. Life became complex, diverse, and it's been evolving ever since. Dinosaurs ruled the Earth for about 165 million years, which is a long time, much longer than mammals have been dominant, much longer than humans have existed. And during that time, dinosaurs evolved into all kinds of forms, huge sauropods, fierce predators, flying pterosaurs, and eventually, birds. Because birds are dinosaurs. They're the only lineage that survived the extinction 66 million years ago. So when you see a bird, you're looking at a dinosaur, a living dinosaur, which is kind of amazing and humbling. Because dinosaurs, they seemed invincible. They were everywhere, dominant, successful. And then an asteroid hit, and most of them died, just like that. Well, not just like that. It took a while. The impact caused massive fires, tsunamis, a global winter, acid rain, the food chain collapsed, and most large animals died. But some survived. Small mammals, some birds, crocodiles, turtles, fish, and life went on. It always does. And mammals, they took advantage of the empty niches. They diversified, evolved, got bigger, more complex, and eventually primates appeared. And then hominids, and then humans, US. We're a very recent addition to the planet. Homo sapiens has only been around for about 300,000 years, which is nothing, a blink. On the timescale of the Earth, we're brand new, and yet we've already had a huge impact. We've changed the atmosphere, the climate, the ecosystems. We've caused extinctions. We've altered the surface of the planet. We've even changed the rock record. Future geologists, if they exist, will be able to see our impact in the layers of rock, the plastics, the concrete, the radioactive isotopes from nuclear tests, the changes in sediment composition. They'll call it the Anthropocene, the age of humans, a new geological epoch, defined by our impact, which is weird to think about. We're creating a layer in the rock record, a marker that will last for millions of years, long after we're gone. And maybe that's our legacy, not our art, not our technology, not our ideas, but a thin layer of plastic and concrete in the geological record. A sign that we were here, that we existed, that we changed things, for better or worse. Probably worse, honestly, because we're not very good at thinking long term. We think in years, decades, maybe a century if we're being generous. But the planet thinks in millions of years, and on that timescale, we're just a blip, a brief moment, a flash. And whatever we do, however much we change things, the planet will recover. Eventually, life will adapt, evolve, fill the niches. New species will appear, ecosystems will rebuild. It might take millions of years, but it will happen. The planet doesn't care about us. It doesn't care about any individual species. It just keeps going, keeps cycling, keeps changing. And in a way, that's comforting, because it means that even if we mess things up completely, even if we cause our own extinction and take a bunch of other species with us, life will continue. The Earth will continue. The continents will keep drifting. The mountains will keep rising and eroding. The oceans will keep circulating. The atmosphere will keep cycling. And eventually, maybe in 100 million years, maybe in 500 million years, someone or something might look back at this time and wonder what happened. Why there's this strange layer in the rocks. Why the fossil record shows a sudden loss of diversity. Why there are all these weird synthetic materials preserved in the sediments. And maybe they'll figure it out. Or maybe they won't. Maybe it won't matter. Because by then, the planet will have moved on, changed, evolved. And whatever came before will just be another chapter in the long, long story of Earth. And the thing is, we like to think we're separate from all this, from the geological processes, from the deep time, from the slow churning of the planet. We live in cities. We have technology. We've built this whole civilization that feels disconnected from the rocks and the magma and the tectonic plates. But we're not separate. Not even close. Everything we do, everything we build, sits on top of this restless planet, and it's still moving, still changing, still doing its thing. The ground beneath your feet right now, wherever you are, is part of a tectonic plate, and that plate is moving, maybe just a few centimeters a year, maybe faster, but it's moving, drifting across the surface of the Earth, like a raft on a very, very slow ocean. Slow, and eventually, millions of years from now, it'll be somewhere completely different. The continents will have rearranged themselves. New mountains will have formed. Old ones will have eroded away. The whole map will look different. And if humans are still around, which is a big if, they'll look back at our maps and think how quaint, how primitive, how wrong we were about the shape of the world. Because the shape is always changing, always has been, always will be. And the ocean floor, that's even more dramatic. Because the ocean floor is young, relatively speaking. The oldest ocean floor is only about 200 million years old, which sounds old. But remember, the Earth is 4.5 billion years old. So the ocean floor is basically brand new. And the reason it's so young is because it's constantly being recycled. New ocean floor is created at mid-ocean ridges, where magma wells up from the mantle and solidifies into new crust. And then that crust spreads outward, moving away from the ridge, getting older as it goes, and eventually it reaches a subduction zone, where it gets pushed down into the mantle, recycled, melted, and the cycle starts over. So the ocean floor is this conveyor belt, constantly being created and destroyed, which means that any evidence of really old oceans, like from billions of years ago, is just gone. Subducted, melted, lost forever. And that's frustrating for geologists, because they'd love to study ancient ocean crust, to understand what the early Earth was like, but it's just not there anymore. The planet has erased its own history, over and over again. And the continents, they're different, because continental crust is less dense than oceanic crust, so it doesn't get subducted as easily. It just kind of floats on top of the mantle, sticks around, which is why we have really old rocks on the continents, rocks that are billions of years old, that have survived multiple cycles of mountain building and erosion and continental drift. They're like the survivors, the ones that made it through, and they tell us stories about what the Earth was like back then, what the atmosphere was like, what the oceans were like, what kind of life existed, if any. And the answer to that last question is complicated, because life appeared pretty early in Earth's history, maybe as early as 4 billion years ago, which is insane, because the Earth was barely formed at that point, still being bombarded by asteroids, still cooling down from its molten beginnings, and yet somehow life started. We don't know exactly how. That's still one of the biggest mysteries in science. How do you get from non-living chemistry to living cells? What's the spark? What's the process? There are theories, ideas about how it might have happened, maybe in hydrothermal vents on the ocean floor, maybe in shallow pools on the surface, maybe even in space, delivered by comets or meteorites. But we don't know for sure. And maybe we'll never know, because the evidence is long gone, destroyed by the planet's own recycling processes. But what we do know is that once life got started, it changed everything. The early Earth had almost no oxygen in the atmosphere. It was mostly nitrogen and carbon dioxide and methane. Not great for us. We'd suffocate immediately. But for early life, it was fine, because early life didn't need oxygen. In fact, oxygen was toxic to most of it. But then, about 2.5 billion years ago, something happened. Cyanobacteria appeared. Tiny little organisms that could do photosynthesis. They could take sunlight and carbon dioxide and water and turn it into energy. And as a byproduct, they produced oxygen. And at first, that oxygen just reacted with iron in the oceans, rusted it, created these massive deposits of iron oxide that we mine today. But eventually, the oceans were saturated. There was no more iron to rust, and the oxygen started escaping into the atmosphere. And this was catastrophic for most life at the time, because oxygen is reactive, it's corrosive, it damages cells. Most organisms couldn't handle it. They died off. It was probably the first mass extinction event in Earth's history, caused by life itself, by pollution, essentially, oxygen pollution, which is ironic because now we think of oxygen as essential for life, but back then it was a poison. And the organisms that survived, they had to adapt. They had to evolve ways to deal with oxygen, to detoxify it, to use it. And some of them figured out how to use it for energy, aerobic respiration, which is way more efficient than anaerobic respiration. You get way more energy out of the same amount of food, and that extra energy allowed for more complexity. Bigger cells, more sophisticated structures, and eventually multicellular life, which took forever to appear, by the way. Life was single-celled for billions of years, just bacteria and archaea doing their thing, evolving, diversifying, but staying small. And then, about 600 million years ago, multicellular life exploded onto the scene, the Ediacaran period. Strange, soft-bodied organisms that don't look like anything alive today. And then the Cambrian explosion, where all the major animal groups appeared in a relatively short period of time, geologically speaking, maybe 20 or 30 million years, which is nothing, a blink. And suddenly the oceans were full of complex life, trilobites, brachiopods, early mollusks, early arthropods, all kinds of weird and wonderful creatures. And from that point on, life just kept getting more complex, more diverse, colonizing new environments, moving onto land, evolving plants, evolving animals, insects, amphibians, reptiles, dinosaurs, mammals, birds. And the whole time, the planet kept changing beneath them. Continents kept drifting, climates kept shifting, sea levels kept rising and falling, and life had to adapt or go extinct, and most species that have ever lived are now extinct. That's just the reality. Extinction is the norm. Survival is the exception. And mass extinctions, those big events where a huge percentage of species die off, those have happened multiple times in Earth's history. The end Permian extinction, the end Triassic extinction, the end Cretaceous extinction that killed the dinosaurs. Each one reshaped life on Earth, opened up new niches, allowed new groups to diversify. And in a way, we owe our existence to these extinctions. Because if the dinosaurs hadn't died out, mammals probably wouldn't have become dominant. We'd still be small, nocturnal creatures hiding from the big reptiles. But the dinosaurs died, and mammals took over, and eventually primates evolved, and then us, and now here we are, living on this restless, changing planet, building our civilizations on top of tectonic plates that are slowly drifting, extracting resources from rocks that formed millions of years ago, burning fossil fuels that are the remains of ancient life, releasing carbon dioxide back into the atmosphere, changing the climate, causing extinctions. And the planet doesn't care. It's been through worse. It's been completely frozen over. It's been hot enough to melt lead. It's been bombarded by asteroids. It's had its atmosphere poisoned by oxygen. It's survived, and it'll survive us too. Whatever we do, however much we change things, the Earth will keep going. The tectonic plates will keep moving. The rock cycle will keep cycling. Life will keep evolving. Maybe not the life we know. Maybe something completely different, but life will persist. Because that's what life does. It adapts. It survives. It fills every available niche. Even the most extreme environments on Earth have life. Deep in the ocean, high in the atmosphere, inside rocks, in boiling hot springs, in frozen Antarctic lakes. Life finds a way. Always has. Always will. And when you think about it like that, it's kind of humbling. Because we're not special. Not really. We're just another species. Another experiment in evolution. Another temporary arrangement of atoms that happens to be self-aware. And will probably go extinct eventually. Maybe soon. Maybe in 1,000,000 years. Who knows? But the planet will keep going. And maybe something else will evolve to take our place. Maybe they'll be smarter than us. Maybe they'll do a better job of taking care of the planet. Or maybe they'll make the same mistakes we did. It's hard to say. But the point is, the Earth doesn't need us. It never did. It was doing just fine before we showed up. And it'll do just fine after we're gone. And maybe that's the lesson here. that we're part of something much bigger than ourselves, much older, much more powerful. The Earth is 4.5 billion years old. It's been through cycles of creation and destruction that we can barely comprehend. It's a dynamic living system, not living in the biological sense, obviously, but living in the sense that it's constantly changing, constantly moving, constantly recycling itself, and we're just passengers on this ride. We didn't build the planet. We didn't design it. We're just here, for a brief moment in geological time. And what we do during that moment, whether we destroy ourselves or figure out how to live sustainably, won't matter in the long run, because in 100 million years the planet will have moved on. The continents will have shifted, the climate will have changed, new species will have evolved, and whatever we left behind will just be another layer in the rock record, another curiosity for future geologists to puzzle over, if there are any. So maybe the real question isn't whether the Earth will survive, because it will. The question is whether we'll survive, whether we can figure out how to live on this planet without destroying ourselves, and that's up to us. The planet's not going to help us. It's not going to slow down the tectonic plates or stop the volcanoes or prevent the ice ages. It's just going to keep doing what it's always done, and we have to adapt, or we don't. And if we don't, something else will take our place, and the Earth will keep spinning, keep drifting through space, keep changing. And maybe that's okay. Maybe that's how it should be. Maybe it's comforting in a weird way, knowing that the planet doesn't depend on us, that it existed long before we did, and it'll exist long after. There's something freeing about that, I think. Takes the pressure off, because we spend so much time worrying about the Earth, worrying about what we're doing to it, worrying about climate change and extinction and all of that. And those are real concerns, obviously. We should worry about them. But maybe we should also remember that the planet itself is going to be fine. It's been through worse, way worse. Asteroid impacts that made nuclear bombs look like firecrackers, volcanic eruptions that covered entire continents in lava, ice ages that turned most of the planet into a frozen wasteland. And it survived all of that. Not just survived, thrived. Because after every catastrophe, life came back. Different life, maybe, but life nonetheless. And that's kind of the pattern, isn't it? Destruction and renewal. Over and over again, the Earth destroys itself and then rebuilds, tears itself apart, and then puts itself back together. And we're just witnessing one tiny moment in that cycle, one frame in a very long movie. And maybe our role in that movie is smaller than we think, or maybe it's exactly as big as we think, but the movie is so much longer than we realize that our part doesn't matter as much as we'd like to believe. Either way, the movie keeps playing, with or without us. And speaking of cycles, let's talk about something that's been cycling for billions of years. Water. Good old H2O. 2 hydrogen atoms, 1 oxygen atom. Sounds simple, right? But water is probably the most important substance on Earth. Without it, life as we know it wouldn't exist. And the water on Earth today, the water you drink, the water in the oceans, the water in the clouds, it's the same water that's been here since the beginning. More or less. Sure, we've lost some to space, and we've gained some from comets and asteroids, but mostly it's the same water, recycled over and over again, for billions of years, which means the water you drank this morning might have been in a dinosaur once, or in an ancient ocean, or in a cloud over a prehistoric forest. It's all the same water, just moving through different forms, different places, different times. That's the water cycle, and it's been happening since the Earth had an atmosphere. Maybe even before that. It's hard to say exactly when the water cycle started, but we know it's been going on for a very long time. So how does it work? Well, the sun heats up water on the surface. Oceans, lakes, rivers, whatever, the water evaporates, turns into vapor, rises into the atmosphere. As it rises, it cools down, condenses into clouds. Eventually, it gets heavy enough that it falls back down as rain, or snow, or hail, or whatever form precipitation takes. And then it flows back into the oceans or lakes or rivers, or it seeps into the ground and becomes groundwater. And then the whole process starts over again. Evaporation, condensation, precipitation, collection, over and over and over. It's a cycle, and it's been running continuously for billions of years. No breaks, no pauses, just constant motion, constant change, and it's powered entirely by the sun. The sun provides the energy that evaporates the water. Gravity brings it back down, and the cycle continues. Simple, right? But also incredibly complex when you start looking at all the details, all the different pathways water can take, all the different forms it can be in, all the different places it can end up. Because water doesn't just stay on the surface, it goes underground too, deep underground, into aquifers and rock layers and all sorts of places we can't see. And it can stay down there for thousands of years, tens of thousands, maybe even longer, just sitting there, waiting, until something brings it back up. A spring maybe, or a well, or tectonic activity that pushes it to the surface. And then it rejoins the cycle, goes back into the atmosphere, falls as rain, flows into a river, into the ocean, and around it goes. And here's the thing, the total amount of water on Earth hasn't really changed much. It's been roughly the same for billions of years. We're not making new water. We're not destroying water. We're just moving it around, changing its form, changing its location, but it's the same water, the same molecules, just rearranged. And that's kind of amazing when you think about it, that the water on Earth is ancient, older than any living thing, older than most of the rocks on the surface. It's been here since the beginning, or close to it, and it'll be here until the end, or close to that too. But the water cycle isn't just about water moving around. It's also about energy moving around. Because when water evaporates, it absorbs energy from the sun. That energy gets stored in the water vapor. And when the water condenses back into liquid, it releases that energy into the atmosphere, which affects the weather, affects the climate, affects everything really. Because water vapor is a greenhouse gas. It traps heat, keeps the planet warm. Without it, Earth would be a frozen ball of ice. But too much of it and things start to heat up. The climate changes. Weather patterns shift. And that's what we're seeing now, kind of. The water cycle is still doing what it's always done. But we've changed the conditions. We've added more greenhouse gases to the atmosphere, more carbon dioxide, more methane. And that's affecting how the water cycle works. It's making it more intense, more extreme, more rain in some places, more drought in others, stronger storms, longer dry spells. The cycle is the same, but the intensity has changed. And that's having all sorts of effects on the planet, on ecosystems, on weather, on us. And it's not just the atmosphere where water matters. It's also underground, in the soil, in the rocks. Because water is one of the main agents of weathering. It breaks down rocks away. And over time, this shapes the landscape, carves out valleys, dissolves minerals, carries them, creates caves, forms soil. Water seeps into cracks in rocks, freezes, expands, breaks the rock apart. That's physical weathering. Or it dissolves minerals in the rock, carries them away in solution. That's chemical weathering. And both of these processes are constantly happening. Everywhere. all the time, slowly but surely changing the face of the Earth. And it's all part of the water cycle, because the water that's doing the weathering eventually evaporates, goes back into the atmosphere, falls as rain somewhere else, and starts the process over again. It's all connected. Everything is connected. The atmosphere, the oceans, the land, the rocks. The water ties it all together, literally. It's the medium through which everything moves, everything interacts. Now let's zoom out a bit, because the water cycle isn't just a local thing. It's not just happening in your backyard or in your city or even in your country. It's global. Water evaporates from the oceans near the equator, rises into the atmosphere, gets carried by winds to other parts of the planet, falls as rain or snow, flows into rivers, back into the ocean, and the whole thing is driven by the sun and by the rotation of the Earth. Because the Earth's rotation affects wind patterns, affects ocean currents, affects where the water goes, and the sun provides the energy to keep the whole system moving. Without the sun, the water cycle would stop. The water would freeze. Everything would freeze. The planet would become a lifeless ball of ice. But as long as the sun keeps shining, the water keeps moving, keeps cycling, keeps sustaining life. Because life needs water. All life, every living thing on Earth depends on water. It's the universal solvent. It's what makes biochemistry possible. It's what cells are made of. It's what plants need to grow, what animals need to drink, what microbes need to survive. Without water, there's no life, at least not life as we know it. And the thing is, Earth is kind of unique in having so much liquid water. As far as we know anyway. There might be other planets out there with oceans, moons with subsurface oceans. We found some candidates: Europa, Enceladus, maybe Titan. But Earth is the only place we know of with liquid water on the surface, in large quantities, stable over billions of years. And that's because Earth is in what we call the habitable zone, the Goldilocks zone. Not too close to the sun where the water would boil away, not too far from the sun where it would freeze solid, just right, at the right distance where water can exist as a liquid. And that's made all the difference, because liquid water is dynamic. It moves, it flows, it transports things, it dissolves things, it facilitates chemical reactions. And all of that is necessary for life. For complex life, anyway. Maybe there's life on frozen worlds, life in ice, life that doesn't need liquid water, but we haven't found it yet. And until we do, liquid water is the key. The thing that makes Earth special, the thing that makes life possible. But here's the catch. Even though Earth is in the habitable zone, it hasn't always been habitable. Not for us, anyway. There have been times in Earth's history when the planet was completely frozen. Snowball Earth, they call it. Happened at least twice, maybe more. The entire planet covered in ice, oceans frozen solid, glaciers covering the continents for millions of years, and somehow life survived. We don't know exactly how, maybe in volcanic hotspots, maybe under the ice near hydrothermal vents, but it survived. And when the ice melted, life bounced back, stronger than before, more diverse, because that's what life does. It adapts, it finds a way, and the water cycle, even when it's frozen, even when it's not cycling in the normal way, it's still there, still waiting, still ready to start moving again when conditions change. And conditions always change, always have, always will. Because the Earth is a dynamic system. It's not static, it's not stable, it's constantly shifting, constantly evolving. And the water cycle is part of that, a key part, maybe the most important part. And it's not just the water itself that's important. It's what the water carries. Nutrients, minerals, sediments. All of that gets transported by water, from the mountains to the oceans, from the land to the sea. And that material, those nutrients, they're what fuel life in the oceans. Phytoplankton need nutrients to grow. They're the base of the marine food chain. Without them, there's no fish, no whales, no nothing. And those nutrients come from the land, washed down by rivers, carried by water. So the water cycle isn't just about water, it's about everything the water carries, everything it connects. It's the circulatory system of the planet, moving nutrients, moving energy, moving life, from one place to another, from one form to another. And it's been doing that for billions of years. And it'll keep doing it for billions more, probably. So when you think about water, when you think about the water cycle, it's easy to take it for granted because it's everywhere. It's constant. It's just there. But it's also one of the most remarkable processes on the planet, maybe in the universe, because it's what makes Earth habitable. It's what makes life possible. It's what connects everything, the atmosphere, the oceans, the land, the rocks, the living things, all connected by water, all part of the same cycle, the same system. And we're part of that system too. We depend on it. We're made of it. Mostly water, humans are, about 60%. 60% water. Just bags of water walking around, thinking, talking, living. And all that water came from the earth, from the oceans, from the rain, from the cycle. And when we die, that water goes back into the cycle, back into the earth, to be used again by something else, someone else, and the cycle continues, always. And maybe that's the real has, always will. Takeaway here, that we're not separate from the earth, we're part of it, part of the system, part of the cycle, and everything system affects that cycle, for we do affects that better or worse. And right now it's kind of for worse. We're changing the climate, changing the water cycle, making it more extreme, more unpredictable, and that's going to have consequences, is already having consequences. But the cycle itself will keep going. The water will keep moving. The planet will keep spinning, with or without us. And maybe that's something to think about as we drift off to sleep tonight, that we're part of something much bigger than ourselves, much older, much more powerful, and that maybe, just maybe, we should treat it with a little more respect. Because respect is maybe what it comes down to, not in some abstract philosophical way, but in a that keep us alive. The water cycle, the carbon cycle, the nitrogen practical sense, respect for the system's cycle, all these processes that have been running for billions of years, long before humans showed up, and they'll keep running after we're gone. Probably. Unless we mess them up so badly they can't recover, which is possible. Not likely maybe, but possible, because we're really good at breaking things, really good at taking systems that work and pushing them until they don't, until they collapse, or change into something else, something we can't live with, and the water cycle is no exception. We're changing it, in ways we don't fully understand, in ways that might not show up for decades or centuries, but they're happening right now, as we speak, as we breathe, as we use water and dump it back into rivers and pump it out of aquifers and change the chemistry of the rain. We're part of the cycle, always have been, but now we're a big part, a really big part. And that comes with responsibility, whether we want it or not. So what are we actually doing to the water cycle? Well, a lot. more than most people realize. Because it's not just about using water, it's about changing where it goes, how fast it moves, what's in it when it gets there. Start with the obvious thing. Dams. We've built tens of thousands of dams around the world, maybe hundreds of thousands if you count the small ones. And dams change rivers. Obviously, they stop the flow, create reservoirs, hold water back, which means that water that used to flow downstream in spring when the snow melted now gets held back, released slowly or not at all, and that changes everything downstream. The timing of floods, the amount of sediment, the temperature of the water, all of it gets altered. And the ecosystems that evolved with those natural patterns, they don't always adapt well to the new patterns. Some species disappear, others take over. The whole system shifts, and we call that management, water management, like we're managing it, like we know what we're doing, but mostly we're just changing it and hoping for the best. And it's not just dams, it's groundwater too. We pump water out of aquifers, underground water that's been sitting there for thousands of years, tens of thousands in some cases. Water that fell as rain back when the Sahara was green, back when mammoths walked around, ancient water, and we're pumping it out faster than it's being replaced, way faster. In some places, the aquifers are dropping by meters every year. Meters. That's insane when you think about it, because that water took millennia to accumulate, and we're using it up in decades, maybe a century if we're lucky. And when it's gone, it's gone. Can't get it back. Not in any time frame that matters to humans. So we're basically mining water, treating it like coal or oil, a resource you extract until it runs out, and then you move on. Except you can't move on from water, you need it. Every day, every hour. So what happens when the aquifers run dry? Good question. Nobody really knows. Because it hasn't happened on a large scale yet. But it will. It's going to. In our lifetimes, probably. In places like India, Pakistan, parts of China, the American Southwest, all these regions that depend on groundwater, that have built their agriculture, their cities, their entire economies around the assumption that the water will always be there. And it won't be. Not forever. Maybe not even for much longer. Then there's the pollution angle, because water doesn't just move, it carries stuff, always has. Sediment, nutrients, minerals. That's natural. That's part of the cycle. But now it's carrying other things too. Things that aren't natural. Chemicals from farms, pesticides, fertilizers, all that nitrogen and phosphorus that we dump on fields to make crops grow faster. And it works. The crops grow, but the excess nitrogen, the stuff the plants don't use, it washes off into streams, into rivers, into lakes and oceans, and that causes problems. Big problems. Because nitrogen is a nutrient, and when you dump a bunch of nutrients into water, things grow. Algae mostly. Phytoplankton. They bloom. Massive blooms that cover the surface of the water. And when they die, they sink, and bacteria decompose them. And that decomposition uses up oxygen. Lots of oxygen. So much that there's not enough left for fish, for anything else living in the water. And you get dead zones. Areas where nothing can live. And they're spreading. Getting bigger every year. In the Gulf of Mexico, in the Baltic Sea, in lakes all over the world. Dead zones caused by too much nitrogen, too much fertilizer, too much of what we thought was helping, turned into poison. Because we didn't think it through, didn't consider what happens when you change the chemistry of water on a massive scale. And it's not just farms, it's cities too. Urban runoff, all the junk that washes off streets when it rains, oil, heavy metals, plastic particles, microplastics everywhere now, in rivers, in oceans, in rain, in snow on top of mountains, everywhere. And we're just starting to understand what that means, what it does to organisms, to ecosystems, to us. Because we drink that water, we filter it, sure, treat it. But those microplastics are so small they get through. They're in our bodies now, in our blood, in our organs. And we don't know what that's doing. Not really. We have theories. We have studies showing it's probably not good. But long-term effects, unknown, completely unknown. Because it's only been a few decades since plastic became ubiquitous, since it got into everything. So we're running an experiment on ourselves, on the planet, and we won't know the results for years, maybe decades, maybe longer. And by then it might be too late to do anything about it. Might already be too late. Hard to say. Climate change is the big one though. The thing that's really messing with the water cycle. Because temperature matters a lot. It determines how much water evaporates, how much the atmosphere can hold, where it rains, how much it rains. All of that is tied to temperature. And we're warming the planet. That's not debatable anymore. It's happening. The average global temperature has gone up about 1 degree Celsius since pre-industrial times. 1 degree doesn't sound like much, but it is. It's huge, because the atmosphere can hold about 7% more water for every degree of warming. 7%. So a warmer atmosphere holds more water vapor, which means when it rains harder, more intense, more extreme. And we're seeing that. Floods are getting worse, more frequent. 100-year floods happening every few years now. Because the definitions we used, the models we built, they were based on historical data, on the past. But the past isn't a good guide anymore. The climate is changing. The water cycle is changing. And our infrastructure, our cities, our farms, they were designed for the old climate, the old water cycle, not the new one. So we're constantly playing catch up, building bigger levees, deeper drainage systems, and it's never enough. Because the problem keeps getting worse, keeps escalating. And it's not just floods, it's droughts too. Because a warmer atmosphere doesn't just mean more rain, it means more evaporation, more water sucking up from the land, from plants, from soil. So dry areas get drier, wet areas get wetter. That's the general pattern. But it's more complicated than that, because atmospheric circulation changes too. The jet stream, the trade winds, all the big patterns that move weather around the planet, they're shifting, weakening in some places, strengthening in others. And that changes where rain falls, where storms form. So places that used to get reliable rainfall, they might not anymore. And places that were dry, they might get floods. The whole system is reorganizing, finding a new equilibrium, or trying to. And we're stuck in the middle of that transition, that reorganization. And it's messy, really messy, because ecosystems can't adapt that fast. Societies can't adapt that fast. We built everything around the assumption that climate is stable, that the water cycle is predictable, and it's not. Not anymore. Maybe it never was completely predictable, but it was stable enough, consistent enough, and now it's not. There's also the ice angle, glaciers, ice caps, all that frozen water, and it's melting. Faster than anyone predicted. Greenland is losing ice. Antarctica is losing ice. Mountain glaciers everywhere are shrinking. Some have disappeared completely. And that water, that meltwater, it goes into the oceans, raises sea levels, which is bad for coastal cities, for islands, for anyone living near the ocean. But it also changes the water cycle. Because that ice, when it was frozen, it was stored water, out of circulation, not part of the active cycle. But now it is. Now it's melting and flowing and evaporating and raining, adding to the total amount of water moving through the system. And that changes things. How much exactly? Hard to say, because the ice sheets are complicated. They don't melt evenly. They have feedbacks, processes that speed up or slow down the melting, and we're still figuring out how all that works, still building the models, still collecting the data. But one thing is clear, the ice is melting, and it's not going to stop, not anytime soon. Maybe not ever. Not unless we cool the planet back down, which seems unlikely at this point, given how things are going. So where does that leave us? With a water cycle that's changing, faster than we expected, in ways that are hard to predict. And we're part of that change. We're driving it through greenhouse gas emissions, through land use changes, through pumping groundwater, through damming rivers, through all the things we do that alter how water moves through the system, and the consequences are starting to show up. More extreme weather, droughts and floods, shifting rainfall patterns, melting ice, rising seas, all of it connected, all of it part of the same system, the water cycle, which isn't really a cycle anymore, not in the simple sense. It's more like a spiral, a system that's evolving, changing, moving towards something new, something we haven't seen before. And we're going along for the ride, whether we like it or not, because we can't opt out, can't step outside the system. We're part of it, dependent on it, made of it. And what happens to the water cycle happens to us. But here's the thing. The water itself doesn't care. It's just molecules, H2O, doing what molecules do, following physical laws, responding to temperature, to pressure, to gravity. It doesn't know we exist, doesn't care if we thrive or die. It'll keep cycling, keep moving, keep changing states, from liquid to vapor to solid and back again, forever, or until the sun expands and boils the oceans away, which won't happen for another few billion years. So the water has time, lots of time. We don't. We're the ones on a clock, the ones who need things to stay stable, predictable, livable, and they're not. Not anymore. And they might not be again. Not in our lifetimes. Maybe not for centuries. Because the changes we've set in motion, they take time to play out. Decades, centuries. The carbon we've put in the atmosphere, it doesn't just disappear, it stays there, warming the planet, changing the climate, altering the water cycle, for a long, long time, longer than any human lifetime, longer than any civilization has existed. So we're committed to some amount of change, some amount of disruption, no matter what we do now, even if we stopped emitting greenhouse gases tomorrow, which we won't. But even if we did, the planet would keep warming for a while, the ice would keep melting, the water cycle would keep changing, because there's lag in the system, inertia, things we've already set in motion that can't be stopped, only slowed down, maybe, if we act, if we change, if we start treating the water cycle, the whole climate system, with the respect it deserves. And maybe that's where we end up tonight, thinking about that, about respect, about responsibility, about being part of something bigger, ancient, powerful, the water cycle that's been running since the oceans formed, since the first rain fell, billions of years of water moving from sea to sky to land and back again. And we're part of that now, a big part, maybe too big, but we're here, we're in it, and what we do matters. How we use water matters, how we treat it matters, whether we see it as infinite or finite, as a resource to exploit or a system to sustain. All of that matters, not just for us, but for everything that comes after, because the water will still be here, the cycle will continue, but whether it's a cycle we can live with, that's up to us. And maybe that's the hardest part, not the science of it, not understanding how evaporation works or where clouds come from or why rain falls. That's all pretty straightforward once you get into it. The hard part is accepting that we're not separate from it, that we don't get to stand outside the system and tinker with it like some kind of machine. We're in it, part of it. And what we do to the water cycle, we do to ourselves. Which sounds obvious when you say it like that. But we don't act like it's obvious. We act like water is just there, like it'll always be there. Turn on the tap and it comes out, flush the toilet and it goes away. Somewhere. We don't really think about where. And for most of human history, that was fine. Because we were small. Our impact was small. The water cycle was so vast, so powerful, so resilient that it could absorb whatever we did. Our waste, our changes, our demands. It didn't matter. The system was bigger than us. But now it's not. Now we're big enough to change things, to alter flows, to warm the atmosphere, to melt the ice, to disrupt patterns that have been stable for thousands of years. And we're doing it, not on purpose maybe, or not entirely on purpose, but we're doing it, and the water cycle is responding, shifting, changing, becoming something new, something we haven't seen before. And we don't know what that looks like yet. Not really. We have models, predictions, scenarios, but they're just guesses. Educated guesses, sure, based on physics and chemistry and lots of data. But still, the system is so complex, so interconnected guesses. Because so full of feedbacks and tipping points and non-linear responses. You change one thing and it affects 10 other things, which affect 100 other things. And pretty soon, you're not sure what's going to happen next, which is scary if you think about it too much, which maybe we shouldn't, not right before sleep. But also maybe we should, because ignoring it doesn't make it go away. The water cycle doesn't care about our schedules, our economies, our political systems. It just does what it does, responds to energy, to heat, to the laws of physics. And right now we're adding energy to the system, a lot of energy, through greenhouse gases, through warming. And that energy has to go somewhere, has to do something. And what it's doing is speeding things up, making the cycle faster, more intense, more extreme, which means more evaporation in some places, more rain in others, more drought here, more flooding there, more snow sometimes, less snow other times. It's not uniform, not predictable, not simple. It's chaotic, in the scientific sense, sensitive to initial conditions, small changes leading to big effects, butterfly wings and hurricanes. Except the butterfly is us, and the hurricanes are real, and getting stronger, because warmer oceans mean more energy for storms, more fuel, more power, and warmer air holds more moisture, which means more rain when it falls, heavier, faster, overwhelming. And that's what we're seeing, not everywhere, not all at once, but in patterns, trends, changes that add up over time, over decades. And they're not stopping, not slowing down, they're accelerating, because the feedbacks are kicking in. The ice melts and reveals dark ocean, which absorbs more heat, which melts more ice. The permafrost thaws and releases methane, which warms the atmosphere, which thaws more permafrost. The forests die from heat and drought and fire, which releases carbon, which warms the planet, which kills more forests. Round and round, each change making the next change more likely, more severe, harder to stop. And here's the thing about the water cycle. It connects everything. Land and ocean, atmosphere and biosphere, living things and dead things, energy and matter. It's the circulatory system of the planet, the thing that moves stuff around. Nutrients, chemicals, heat. Life itself, in a way. Because without water, there's no life. Not as we know it. Not complex life. Not us. So when we change the water cycle, we're changing the conditions for life, making some places more habitable, some places less, shifting the boundaries, the limits, the possibilities, and life responds, moves, adapts, evolves, dies, sometimes all at once, sometimes slowly, over generations, over centuries, but it responds, has to respond, because the environment is changing, the rules are changing. What worked before doesn't work now. What was stable is now unstable. What was predictable is now chaotic. And organisms either cope or they don't. Populations either survive or they collapse. Ecosystems either adapt or they transform into something else. Something new. Something we don't have a name for yet. And humans, we're part of this too. We like to think we're separate, special, above nature, but we're not. We're just another species trying to make it in a changing world. And yeah, we have technology, tools, knowledge. We can adapt faster than most species, build things, move things, change things, but we're still dependent on the water cycle, on rain falling in the right places at the right times, on rivers flowing, on aquifers recharging, on snow melting at the right rate, on all the pieces working together in a way that supports agriculture, cities, civilization. And when those pieces don't work together anymore, when the patterns break down, we struggle, we fight, we migrate, we collapse. History is full of civilizations that fell apart when the water cycle changed, when the rains stopped, when the rivers dried up, when the climate shifted. It's happened before. It'll happen again. Maybe it's happening now, in slow motion. Too slow to see in real time, but fast enough to matter. Fast enough to change everything over a lifetime, over a generation. The ancient civilizations, they understood this. Maybe not the science, not the mechanisms, but they understood the importance of water, the power of it, the necessity. They built their societies around it, around rivers, around rain, around springs and wells and aquifers. They worshipped water gods, made offerings, prayed for rain, built temples near water sources, because they knew that without water, they were done. And when the water failed, when the rains stopped or the rivers changed course, those civilizations fell. Sometimes quickly, sometimes slowly, but they fell. And we think we're different, that we're immune, because we have dams and pipelines and desalination plants, because we can move water around, store it, treat it, use it more efficiently, and that's true. We can do all those things, but we can't make more of it, can't create water that doesn't exist, can't change the fundamental fact that fresh water is finite, limited, and unevenly distributed. Some places have too much, some places have too little, and as the climate changes, as the water cycle shifts, those imbalances are getting worse. The wet places are getting wetter, the dry places are getting drier, and the places in between, where most people live, are becoming more unpredictable, more variable, harder to plan for, harder to adapt to, because you can't build infrastructure for both floods and droughts, can't prepare for both too much rain and not enough, not easily, not cheaply, not fast enough to keep up with the changes. So what do? That's the question, right? That's what we're supposed to be thinking about. Maybe. Or maybe we're supposed to just be drifting off, thinking about water moving through the atmosphere, through the soil, through our bodies, the eternal cycle, the ancient rhythm, because there's something calming about that, about cycles, about things that repeat, that continue, that persist. Even as everything else changes, the water cycle will keep going, has to keep going. It's physics, chemistry, thermodynamics. The sun will keep shining, The oceans will keep evaporating. The rain will keep falling. Somewhere, somehow, maybe not where we want it, maybe not when we need it, but it'll keep happening, keep cycling, keep moving, because that's what water does. That's what it's always done. Since the beginning, since the planet cooled enough for oceans to form, since the atmosphere stabilized, since life began, the water cycle has been running, shaping the planet, creating conditions for life, for us, and it'll keep running, long after we're gone. If we're gone, which maybe we won't be, maybe we'll figure it out, learn to live with a changing water cycle, adapt our systems, our societies, our expectations. Stop pretending we're in control. Stop acting like we can just keep taking and using and changing without consequences. Maybe we'll get smarter, more careful, more respectful, or maybe we won't. Maybe we'll keep doing what we're doing until the system breaks, until the water cycle shifts so far that our civilizations can't function anymore, can't feed themselves, can't sustain themselves, and then we'll collapse, like civilizations before us, and the water cycle will keep going, keep cycling, indifferent, eternal, just molecules moving through states, through space, through time. But tonight, right now, as you're drifting towards sleep, maybe it's enough to just think about the water, the rain outside if it's raining, the moisture in the air, the glass of water on your nightstand, the rivers flowing somewhere out in the dark, the oceans rolling and churning, the glaciers melting, slowly, inexorably, feeding rivers that billions of people depend on, all of it connected, all of it part of the same cycle, the same system. And you're part of it too, breathing out water vapor with every breath, sweating, drinking, peeing, crying maybe, all of it water, moving through you, moving through the system, part of the cycle. And maybe there's something profound in that, something humbling, being part of something so vast, so ancient, so powerful. Or maybe it's just physics, just chemistry, just molecules doing what molecules do, following laws that don't care about meaning or purpose or significance, that don't care about anything, because they're not alive, not conscious, not aware. They just are. And they'll keep being, keep cycling, keep moving, forever, or until the sun dies, which is basically forever from our perspective. So the water has time, all the time in the world. We're the ones who don't. We're the ones who need to figure things out, soon, before the changes get too big, too fast, too irreversible. And maybe we will. Maybe we'll rise to the occasion, use our big brains and our technology and our capacity for cooperation to solve this, to stabilize the climate, to protect the water cycle, to build a sustainable relationship with the planet that sustains us. Or maybe we won't. Maybe we'll fail. Maybe it's already too late. Maybe the changes we've set in motion are already unstoppable. Maybe we're just along for the ride now, watching the water cycle transform into something new, something we've never seen before, something that might not include us, or might include us, but in a different form, a smaller form, a humbler form, living in a world that's hotter, wetter, drier, more extreme, less predictable, harder to survive in, but still here, still alive, still part of the cycle. Because that's the thing about life. It's resilient, adaptable, persistent. It finds a way, even when conditions change, even when the environment shifts, even when the water cycle transforms. Life adapts, evolves, continues in new forms, new configurations, new relationships. And maybe that's what we're seeing now. The beginning of a new chapter, a new phase. Not the end of the story, but a transition, a transformation from one state to another. Like water changing from liquid to vapor, from ice to liquid, different form, same substance, same molecules, just arranged differently, behaving differently, existing in a new way. And maybe that's what's happening to us, to our civilization, to our relationship with the planet. We're changing states, transforming, becoming something different, something new, and we don't know what that looks like yet. Can't see it clearly, because we're in the middle of it, in the transition, in the turbulence, where everything is uncertain, chaotic, unstable. But eventually things settle, find a new equilibrium, a new balance, a new way of being, and maybe that's where we're headed, toward a new normal, a new relationship with water, with climate, with the planet, one that's more sustainable, more balanced, more respectful, or maybe not. Maybe we're headed toward collapse, toward breakdown, towards something darker, something harder, something we don't want to think about too much, especially not before sleep. But maybe that's okay. Maybe uncertainty is part of the deal, part of being human, part of living on a planet that's alive, dynamic, constantly changing. We want stability, predictability, control. But the Earth doesn't offer that. Never has. Never will. It's always been a moving target. Always will be. And the water cycle is just one expression of that. One way the planet shows us it's not static, not fixed, not ours to command. It does what it does, follows its own rules, its own patterns. And we're along for the ride, whether we like it or not, whether we understand it or not, whether we're ready or not. The thing is, though, we're not just passengers, not anymore. Maybe we never were, but definitely not now. We're participants, active ones, changing the game, altering the rules, affecting the outcome, for better or worse. Mostly worse, probably, but also maybe better, if we figure things out, if we learn, if we adapt, if we change our behavior, our systems, our relationship with the planet, with water, with the cycle that sustains us, because that's what it comes down to. Really, the water cycle sustains us, feeds us, gives us life, makes everything possible. Without it, we're nothing, just dust, just bones, just molecules waiting to return to the earth. But with it, we're alive, conscious, aware, capable of understanding, of appreciating, of protecting, or destroying. The choice is ours, sort of, as much as any choice is ours when we're part of a system this big, this complex, this interconnected. And maybe that's the real lesson here, the real takeaway. Not that the water cycle is fragile, or that we're destroying it, or that we need to fix it, but that we're part of it, inseparable from it, made of it, sustained by it, connected to it in ways we barely understand, ways we're only beginning to appreciate, ways that matter more than we realize. Every breath you take involves water, vapor in the air, moisture in your lungs. Every cell in your body is mostly water. Every thought you think happens in a brain that's about 75% water. Every emotion you feel is carried by chemicals dissolved in water. Neurotransmitters floating through fluid. Hormones traveling through blood, which is mostly water. Everything is water, or involves water, or depends on water, in some way, direct or indirect, obvious or subtle. So when we talk about the water cycle, when we study it, learn about it, worry about it, we're really talking about ourselves, our lives, our future, our survival, not in some abstract way, but in the most concrete way possible, the most immediate way, the most essential way. Water is life. The cycle is life. Disrupting it means disrupting life. Our life. All life. Everything. And that's heavy. That's a lot to carry, a lot to think about, a lot to process, especially when you're trying to sleep, trying to relax, trying to let go of the day and drift off into unconsciousness, into dreams, into whatever state we go to when we're not awake, not thinking, not worrying, not aware. But maybe that's okay too. Maybe it's good to think about this stuff, to understand it, to appreciate it, before you sleep, before you let go, because when you wake up tomorrow, you'll still be part of the cycle, still drinking water, still breathing it, still depending on it, still affecting it, still connected to it. And maybe, if you understand it better, appreciate it more, you'll make different choices, small ones, big ones, choices that matter, that help, that protect the cycle, that sustain it, so it can sustain you and everyone else and everything else forever, or as close to forever as we can get. The water that falls as rain today, that soaks into the ground, that feeds the plants, that fills the rivers, that flows to the sea, that evaporates into clouds, that falls again tomorrow. That water has been doing this for billions of years, since the earth was young, since the oceans formed, since life began. It's the same water, the same molecules, just moving, cycling, transforming, endlessly. And you're part of that now, temporarily, briefly, for the span of your life, which is nothing compared to the age of water, nothing compared to the time the cycle has been running. But still, you're part of it. Right now, in this moment, as you lie here, breathing, existing, being. You're made of water that fell as rain somewhere. Sometime, maybe recently, maybe long ago, maybe in a place you've never been, a place you'll never go. But the water went there, and then it went somewhere else, and eventually it ended up in you, in your body, in your cells, in your blood, in your brain. And one day, it'll leave, slowly, through breath, through sweat, through tears, through waste. The water will leave your body, return to the cycle, evaporate, condense, fall, flow, evaporate again, become part of something else, someone else, some other living thing, some other part of the system, and your body will return to the earth, break down, decay, release its elements, its minerals, its molecules, back into the soil, the water, the air, the cycle. That's the deal. That's how it works. Has always worked, will always work. We're temporary configurations, brief arrangements of atoms, borrowed from the earth, animated by energy from the sun, sustained by water from the cycle, and then returned, given back, released. So the cycle can continue, so the system can persist, so life can go on, in new forms, new configurations, new arrangements. It's beautiful, really, when you think about it. The continuity, the connection, the way everything is linked, the way nothing is wasted, nothing is lost, everything is recycled, reused, repurposed, over and over, forever. The same atoms, the same molecules, the same water, just moving, changing, becoming, different things at different times, but always part of the same system, the same planet, the same story. And our story is part of that larger story. Our lives are chapters in the Earth's ongoing narrative, brief chapters, short ones, but chapters nonetheless, with beginnings, middles, ends, and then the story continues, without us, but because of us, because we were part of it, because we contributed, in ways big and small, good and bad, intentional and accidental. We left our mark, changed the plot, affected the outcome. For the characters that come after, the future chapters, the continuation of the story. So maybe that's the responsibility, the challenge, the opportunity, to make our chapter a good one, a useful one, a chapter that helps the story continue. That doesn't end it prematurely. That doesn't make things harder for the chapters that follow. That contributes something positive, something valuable, something that matters. And how do we do that? How do we write a good chapter, make a positive contribution, leave things better than we found them, or at least not worse? Maybe it starts with understanding, with learning, with appreciating the system we're part of, the cycle that sustains us, the water that gives us life. Maybe it continues with respect, with humility, with recognizing our place, our role, our impact. And then maybe it ends with action, with choices, with behaviors that protect rather than harm, that sustain rather than destroy, that give back rather than just take. Or maybe it's simpler than that. Maybe it's just about paying attention, noticing, being aware of the rain when it falls, the rivers when they flow, the clouds when they form, the water when you drink it, the moisture in the air, the cycle in action, all around you, all the time, constant, eternal, beautiful. Because when you pay attention, when you notice, when you're aware, you can't help but be grateful, can't help but appreciate, can't help but feel connected to something bigger than yourself, something older, something more important, something that will outlast you, that existed before you, that will exist after you, but that includes you right now, in this moment, as part of its endless dance. And maybe that's enough. Maybe that's all we need. To be aware, to be grateful, to be connected, to understand that we're part of something magnificent, something beyond our full comprehension, something that doesn't need our permission or our approval, but that gives us life anyway, that sustains us anyway, that includes us anyway, despite our flaws, our mistakes, our limitations. The water cycle doesn't judge, doesn't discriminate, doesn't choose. It just is, just does, just continues, day after day, year after year, millennium after millennium, giving life, taking it away, giving it again, in an endless rhythm, an eternal pattern, a dance that never stops. And we're part of that dance, whether we realize it or not, whether we want to be or not, whether we understand it or not. We're dancing right now with every breath, every heartbeat, every thought. We're moving with the cycle, moving through it, being moved by it, part of something vast, something ancient, something that connects us to everything else, everyone else, every living thing, every drop of water, every cloud, every ocean, every river, every raindrop. So as you drift off to sleep tonight, as your breathing slows, as your thoughts quiet, as consciousness fades, remember that you're not alone, you're not separate, you're not isolated, you're connected, deeply, fundamentally, inextricably, to the earth, to the water, to the cycle, to everything. And tomorrow, when you wake, when you drink your first glass of water, when you feel the rain on your skin, or see the clouds in the sky, remember that too. Remember that you're part of something bigger, something beautiful, something worth protecting, worth understanding, worth appreciating. The water cycle will continue, with or without us, but we get to choose how we participate, how we contribute, how we affect it. And maybe, just maybe, if we choose wisely, if we act thoughtfully, if we learn and adapt and change, we can be part of it for a long time, a very long time, long enough to write many more chapters, many more good chapters, in the Earth's ongoing story. Sweet dreams, and may the cycle continue forever. So maybe that's where we land tonight. thinking about this planet we call home, this blue marble spinning through space, this collection of rock and water and air that somehow, against all odds, became the perfect place for life, for us, for everything we know. It's easy to take it for granted, easy to forget how remarkable it all is, how unlikely, how precious. We wake up every day on solid ground. We breathe air without thinking about it. We drink water from a tap. We look up at a sky that's been there forever, or so it seems. But none of it is permanent. None of it is guaranteed. The Earth has been through so much. Ice ages, asteroid impacts, mass extinctions, volcanic eruptions that covered continents, climate shifts that transformed everything. And it survived, not just survived, thrived, changed, evolved, became something new each time, something different, something that could support life in new forms, new configurations, new possibilities. And we're here now, at this particular moment in Earth's history, this particular configuration, this particular state. And it's changing, right now, as you lie here, as you breathe, as you drift towards sleep. The continents are moving, imperceptibly, but moving. The climate is shifting. The water cycle is changing. The magnetic field is fluctuating. The core is churning. The mantle is flowing. The crust is cracking and reforming. Nothing is still. Nothing is static. Everything is in motion, has always been in motion, will always be in motion. That's what Earth does. That's what it is. A dynamic system, a living planet. Not living in the biological sense, but living in the sense that it's constantly changing, constantly evolving, constantly becoming something new. And maybe that's the most important thing to understand. That change is the only constant, that nothing on Earth lasts forever. Not mountains, not oceans, not species, not civilizations. Everything is temporary. Everything is in transition, from one state to another, from one form to another, from one era to another. And we're part of that transition, part of that change, part of that evolution, whether we like it or not, whether we're ready or not, whether we understand it or not. We're here, in this moment, on this planet, part of its story, part of its journey, part of its becoming. And what we do matters. How we treat the planet matters. How we use its resources matters. How we affect its systems matters. Not because the Earth needs us. It doesn't. It never has. It was doing fine before we showed up. It'll do fine after we're gone. But because we need it, we need the air, the water, the soil, the climate, the ecosystems, all of it. We're completely dependent on this planet, on its systems, on its cycles, on its stability, or relative stability. And when we disrupt those systems, when we change those cycles, when we destabilize that stability, we're really just making things harder for ourselves, for our children, for future generations, for all the living things that share this planet with us. But there's hope too, because we're also the first species, as far as we know, that can understand all this, that can study the planet, measure its changes, predict its future, and maybe, just maybe, change our behavior in response, adapt, evolve, not biologically, not over millions of years, but culturally, technologically, within decades, within years. We have that capacity, that potential. We've done it before, changed course, solved problems, fixed mistakes. Sometimes, not always, not often enough, but sometimes. And maybe we can do it again. With the climate, with the water cycle, with biodiversity, with all the systems we've disrupted. Maybe we can figure it out, find a way to live on this planet without destroying it, without destroying ourselves in the process. Or maybe we won't. Maybe it's too late. Maybe the changes are already too big, too fast, too irreversible. Maybe we're past the point of no return, past the tipping point, into a future that's hotter, harsher, harder to survive in. Maybe our civilization will collapse. Maybe our species will go extinct. Maybe we're just another chapter in Earth's long story, a brief chapter, a cautionary tale about what happens when a species gets too successful, too powerful, too disconnected from the systems that sustain it. But even if that happens, even if we fail, even if we're gone, the Earth will continue. The story will continue. Life will continue. Maybe not human life, maybe not the life we know, but life, in some form, some configuration, some arrangement of atoms and molecules and cells and organisms. Because that's what life does. It persists, it adapts, it evolves, it finds a way, always has, always will. As long as there's liquid water, as long as there's energy from the sun, as long as there's carbon and nitrogen and all the other elements, life will figure it out. We'll keep going. We'll keep trying. We'll keep becoming. And the planet will keep spinning, keep orbiting the sun, keep cycling through its systems, its processes, its changes. The continents will keep drifting. The mountains will keep rising and eroding. The oceans will keep circulating. The atmosphere will keep cycling. The rock cycle will keep recycling. The water cycle will keep cycling. All of it. Forever. Or as close to forever as makes no difference. Until the sun expands. Until the earth gets swallowed. Until the end, which is billions of years away. So long that it might as well be forever. From our perspective. From our tiny slice of time. So tonight, as you drift off, as sleep takes over, as consciousness fades, think about that, about being part of something so vast, so ancient, so enduring, about living on a planet that's been here for 4.5 billion years, that will be here for billions more, about being a temporary arrangement of stardust, of atoms forged in dying stars, of molecules that have been cycling through this planet since the beginning. You're not separate from Earth. You're part of it, made of it, sustained by it, connected to it in ways profound and simple, obvious and subtle. You breathe its air, drink its water, eat its life, walk on its surface, sleep under its sky. You are Earth, temporarily, briefly, for this moment, for this lifetime, and then you'll return. Back to the soil, back to the cycle, back to the planet, and the story will continue, with or without you, with or without us. The Earth story, the long, long story, that started billions of years ago and will continue for billions more. A story of change, of adaptation, of survival, of beauty, of wonder, of life finding a way, always finding a way, no matter what. That's Earth, our marvelous planet, our temporary home, our only home, for now, for always, for as long as we're here, spinning through space, carrying us along, part of something bigger, something older, something more important than we can fully comprehend, but something we can appreciate, something we can protect, something we can honor by understanding it, by respecting it, by living in harmony with it, or at least trying to. That's all we can do, really. Try, learn, adapt, change, grow, and hope that's enough. Hope we figure it out before it's too late, before the changes overwhelm us, before the systems collapse, before the story ends. Our story, humanity's story, the brief chapter we're writing, right now, tonight, as you drift off to sleep, on this marvelous planet, this blue marble, this home, this Earth.